everybody, welcome back to chemistry. If I can blow up the slide, please. So this is Achieve 9, question 5, qualitative bond polarity in 3 structures. It says, for each bond, select the arrow that indicates the direction of bond polarity. So if I can reduce the slide. What they're focusing on here is one molecule, and the molecule is written out like this, but let me show you another structure of the molecule. It may be a little bit easier to understand if I draw it this way. So the molecule really looks like this. There's fluorine, and it's bound to a carbon. You see this H3 here? Keep in mind that implies that there's single bonds to the carbon like that. Okay, so this is really what the molecule looks like. And so the first thing you have to do is you have to figure out the correct polarity of the bond. In other words, you have basically 2 atoms at the end of this bond. One atom is a fluorine, another atom is carbon attached to these hydrogens. And so you have to figure out whether the electron density is more toward the fluorine than the carbon, or is the electron density more toward the carbon than the fluorine. That will tell you the polarity of the bond. And so the only way you can really work that out is by looking up what the electronegativities of these atoms are. Okay, so let me kind of just walk you through this. Okay, so we have a table of electronegativities there, and so you can look up fluorine's electronegativity, and you will find the electronegativity of fluorine is 4.0. Now, you can look up the electronegativity for carbon. The electronegativity of carbon is 2.5. Now, these are the 2 atoms that are attached in the bond, so you really don't have to worry about the electronegativities of the hydrogens here. So again, we're only trying to look at this bond here to see what is the polarity of the bond. Okay, next we have to figure out in this bond which side is relatively negative and which side is relatively positive. So let me remind you how to do that. So you recall that in a bond, a single bond, there's a pair of electrons. And you may recall that these pair of electrons could be shared equally between the fluorine and the carbon, but only if the electronegativities of these 2 atoms are the same. That's not the case. Fluorine has a greater electronegativity than carbon, and so that predicts that this pair of electrons will not be equally shared between fluorine and carbon. And in fact, you may recall that the definition of electronegativity is it's a value that tells you the relative strength that the atom nucleus has for a shared pair of electrons. So fluorine has a greater attraction for a shared pair of electrons than carbon. So these electrons here are going to be spending a lot of time around fluorine and a little bit less time around carbon. So a lot of time around fluorine, a little bit less time in carbon. So that tells us where the negative and positive ends of the bond are. And so the negative end is over fluorine because the electrons are spending more time there. To indicate that fluorine has this negative end here, we put delta minus. The carbon, the electrons are spending less time around there, and so this is the delta positive end. Okay, so we figured out the polarity of the bond, and so what you have to do to sort of complete the answer on Achieve is for you to indicate that you know that basically the electron density is going to the left, meaning that we have here on the right side where the carbon is relatively low electron density, and then on the left side relatively high electron density. And we do that with an arrow. And so the base of the arrow will be over the atom, which has the lower electronegativity. The tip of the arrow is going to be over the atom with the higher electronegativity. So here we have to draw the arrow like this. So you're going to have to draw in an arrow like that for your answer. And so this indicates here that this bond is polar, meaning it has sides to it. One side is negative, that's where the arrow tip is, and one side is positive. Okay, let's do this one really quickly. So it's kind of the same situation. So in that we're really focusing on the bond here between carbon and nitrogen there, but let me go ahead and draw out a picture of the molecule. It looks like this. And so nitrogen here actually has a lone pair. Okay, and so what they want you to do is figure out what the polarity of the carbon-nitrogen bond is. And so you do it in the same fashion. And so you can look up the electronegativity of carbon. Again, it's 2.5. You can look up the electronegativity for nitrogen. As I recall, it's 3.0. Okay, so that tells us that this pair of electrons here in the single bond between carbon and nitrogen is going to want to spend slightly more time around nitrogen than carbon. Therefore, the nitrogen end is delta negative, the carbon end is delta positive. And so what you have to do is draw a dipole moment arrow, one of these things here that depicts that. And so the base of the arrow goes from the end with the lesser electronegativity and points to the end with the greater electronegativity, so it looks like this. I'm going to let you figure out this last one on your own, but you're essentially going to need two arrows. An arrow for the bond on the left and an arrow for the bond on the right. Thank you for listening. We will see you next time.